channel. In today's video, I'll be talking about the next topic in thermodynamics, which is on work and heat transfer. Okay, so let's begin the video. Now, in the introduction video, we'll be talking about what is work transfer and what is heat transfer, and the coming videos will be continuing with the topic. Okay, so if a closed system has to interact with the surrounding, okay, then it can happen only with the help of a work transfer and a heat transfer. Okay, so closed system can interact with the surrounding by work transfer as well as by heat transfer. Okay, so the closed system can interact with the surrounding by work transfer and heat transfer. Now let's get into depth on what is heat transfer and what is work transfer. Okay, I'll begin with heat transfer and then I'll go to work transfer. Now, what is heat transfer? Okay, it is heat. It is two words, which is heat and transfer. Okay, let's begin with the first word, which is heat. So what is heat? Okay, heat is a form of energy, right? So heat is a form of energy which is a function of time. Which is a function of temperature. Right? So heat is a form of energy which is a function of temperature. So more the temperature, more is the heat. Okay, now let's get into the topic on what is heat transfer. Okay, as the name suggests, it's transfer, which means that it is the energy is getting transferred. Okay, now how does this heat transfer occur? Okay, now let's consider if I have a glass. Okay, say this glass is filled with tea and is having 80 degrees Celsius. Okay, and the surrounding temperature is say 20 degrees Celsius. Okay, so now let's consider this to be the system and the outside as the surrounding. Okay, so this is where heat transfer occur. So the heat will go out from the hotter body to the cooler side, right? From the hotter side to the cooler side. So that is what heat transfer means. Okay, so heat transfer is what in definition? Heat transfer, it is a form of energy. It is a form of energy which is transferred between two systems or between a system and a surrounding by virtue of a temperature difference only. Okay, virtue of temperature difference only. So this you will have to remember. Okay, heat transfer occur only when there is a temperature difference. Okay, so for example, if this is 80 degrees Celsius, consider this as the tea, and there is a cooler body which is of 20 degrees Celsius. Okay, so the heat transfer occur only when there is a temperature difference. So this is how the heat transfer occur. So I hope this is clear for you on what is heat transfer. Okay, now let's talk about the second type of transfer, okay, which is the work transfer. Now, in our lower classes we studied work. Okay, the work which we studied in the lower class is in mechanics, or in mechanical point of view, the work can be defined as the work which is done by a force as it acts upon a body moving in the direction of force, which means that if I have a wood Okay, suppose if I have some object, say, okay, suppose if this is an object, okay, which is placed on the surface, and I'm moving it with some force F, and it has moved a distance of S. Okay, so what is the work done here? The work done is a product of force into the distance. So this work is in point of mechanics. Now in thermodynamics, work transfer, it is, the definition is different. Okay, so in thermodynamics, the work done, okay, the work will be done only if the sole effect on things on the external to the system can be equated by raising of weight, which means that or we can say that if the system crosses the system, if the system crosses the surrounding, we call it as a work transfer. Now I'll take an example here. Okay, suppose if I have a battery. Okay, suppose if this is a battery. Okay, and it is connected to a motor. Okay, it is connected to a motor, and the motor is then connected to a pulley which carries some weight. Okay, so this is the weight, okay, and this is the pulley. Now let's consider the whole motor and the battery if I consider it to be a system. Suppose if this is a system. Suppose if this is a system and this is a surrounding. Okay, here there is a work transfer because the system crosses the surrounding. Only if the system crosses the surrounding, there is a work transfer. So in thermodynamics, if the system crosses the surrounding, we call it a work transfer. Okay, so let's write a definition on that. Okay, so the definition is, the work is said to be done in thermodynamics, the work is said to be done, okay, if sole effect on things external to the system can be equated by raising of weight. Okay, so this is the definition on thermodynamic work transfer. So just remember that if the system crosses the surrounding, we call it a work transfer in thermodynamics. Now let's take another example with the same example. If I have the same example, say battery I have, which is connected to a motor. Okay, and the motor is then connected to a pulley which is then used to raise the weight. Okay, now if I consider the whole thing as the system, will there be a work transfer here? No. The work transfer is 0 in the case, because thus the whole system we consider to be a system and the outside is the surrounding. Right? So the system does not cross the surrounding. So we call this, we won't call this as a work transfer. So the work transfer here is 0. So the work transfer, okay, is 0. So we can call this as the free expansion. Okay, so this is the idea on work transfer and heat transfer. So in the coming videos, we'll be going into depth on the different types of work transfer as well as on the heat transfer. So if you have any doubt regarding this video, do comment in the comment section so that I can clear your doubts in the coming videos. So thank you.